Here we're given two functions. F of x equals negative 7x plus 2 is the first function, and g of x equals x minus 4 is the second function. We know they are two different functions. One is noted as f of x and one is noted as g of x. There's no difference between these two except for what they equal, and these are just names. The f of x and g of x are just names to distinguish the difference between these two functions. So the idea is whatever is in here, we're going to plug into the x value. So for instance, if there's a number in there, we're going to take that number and plug it in every time we see x. So for instance, the best way to work out a problem like this, we have f of negative 6 here. We're going to take negative 6, and every time we see x, we're going to plug in negative 6. So I'm going to rewrite this function down here as negative 7x plus 2. But notice how instead of x, I put a set of parentheses. At this time, I want you to fill in what you think goes in those parentheses based on what I said. You should have filled in negative 6. Because this function is f of negative 6. Every time you see x, you should plug in negative 6 for x. But we're not done yet. We still have to simplify. Negative 7 times negative 6, we're using order of operations here. Negative 7 times negative 6 is 42. Plus 2. So my value, f of negative 6, gives me 44. What that means is every time I plug in negative 6 for this function, I will get 44 as a result. So that is my final answer. You're not always going to plug in a number to these functions. Sometimes you're going to plug in numbers, variables, or expressions. So for this next one, we're using g, so we're going to use this function. And it's the same thing. Every time we see x, we're going to plug in this value for x. So my function is x minus 4. My x value in g of x is now d plus 3. It is okay to have a variable. So if that's the case, I'm going to plug in d plus 3 to where x used to go. It's okay to have a variable. We're not always going to have a number as an answer. So we simplify our like terms. This is the same thing as just d plus 3 without parentheses minus 4. So once we combine our like terms, we get d minus 1 or d plus negative 1. This ends up being our answer to g of d plus 3. The next example has two functions in it. I'm going to go ahead and do the first one in purple. The first one is f of 4. I'm going to underline that in purple so you can see. So that means every time I see x for f, I'm going to plug in 4. So I'm going to write down this formula. Negative 7x plus 2. I'm going to plug in 4 for x. Then I want you to notice how we're adding this whole thing. So we're adding this whole function to g of a. So I'm going to do that one in orange. So I'm going to write this one in orange. G of a. We're adding this whole thing to our original function in purple. So we're adding x minus 4 because that is my function up here. Every time I see an x value, that's going to be this right here because this is x minus 4, I'm going to plug in whatever's inside these parentheses. That's going to be a, so I'm going to plug in a. I'm going to use a different color at this point because what I'm going to do is simplify. I'm going to simplify by combining like terms and using order of operations. I have negative 7 times 4 is negative 28 plus 2 plus a minus 4. Once you combine all your like terms, you end up with a. Nothing combines with a. And then you add negative 28 plus 2 is negative 26. Negative 26 minus 4 is negative 30. So your final answer for this problem is a minus 30. That is the answer to f of 4 plus g of a.